Hey everyone, Morgan here. So we're talking about gases, Unit 8, Honors Chemistry. We're on page number 4 of the outline today, and we're going to be doing some problem solving. So a lot of what I want to focus on today is as much technique as it is actual answers. So let's go through and read the first one. What's the pressure? So I'm looking for a pressure. When 10.0 liters of argon, that's a volume because it's in liters, at 5.00 atmospheres, that's a pressure because it's in atmospheres, is compressed to 5.0 liters, and that's a volume. So I know that having this word at, 10 liters of argon at 5 atmospheres, means those go together. So we'll call those P1 and V1. Okay, that would make this P2 and V2. Now I am looking for pressure. I know this is going to be Boyle's law because all I see is pressure and volumes. P1 V1 equals P2 V2. So P2 is going to equal P1 V1 over V2 equals. Now, I have 5.00 atmospheres as my first pressure. Okay, that's at 10.0 liters. And then I'm going to compress that to 5.0 liters. There's just 1 0 there. That's going to limit my sig figs. Liters cancels liters. I am left over with the unit atmospheres, which is good. Okay, now this math I can actually do in my head. 5 over 5 is 1 times 10, so the answer must be 10. Give it a decimal point because this has 2 sig figs, and that's 3 and that's 3, so my answer can only have 2. So 10.0 atmospheres. Now that's the type of approach I'd really like to see you take with all of the questions. Okay, let's go on now to the second one. A balloon is filled. You've got 700 milliliters of gas at 20 degrees, so this is a volume. This is a temperature. I'm going to have to do that into Kelvin. 20 plus 273 is 293 Kelvin. The balloon is then cooled to 100 Kelvin. What is the final volume? So that's a V. Now, these go together because of the word at, so I'll make this V1 and T1. It's cooled to 100 Kelvin. We'll make that T2. This is V2. V1 over T1 equals V2 over T2. V2 equals, I just multiply both sides by T2. That cancels, and I get V1 T2 over T1. All right. So 700 milliliters, it has the decimal point. I don't really have to change this to liters. I'll just get my answer in milliliters and that'll be okay. T1 is 293 Kelvin, and up here I have 100 Kelvin. The kelvins are going to cancel, equals. So what I can do is take my calculator here and do 700 times 100 divided by 293, and I'm getting 238.9. Okay, I'm limited to 3 sig figs, okay, the way this is set up. All right, so 239 milliliters. Okay, now I'm trying to map out a way of labeling things, a way of setting up the algebra, unit canceling, that's going to help you as you go through and do all of these questions. Okay? So please follow that technique. What is the temperature when 3.75 liters? That's going to be a volume of neon at 25 degrees. That's a temperature. 298 K. All right, is compressed to 3.5 liters. That is another volume. Okay, so 3.75 atmospheres, so those go together. So we'll make that V1 and T1. Okay, we'll make this V2, and we're looking for T2. So I can write V1 over T1 equals V2 over T2. I'm just going to invert that and go T1 over V1 equals T2 over V2. That's proper algebra. And then I can multiply both sides by V2. V2 cancels, and T2 equals V2 T1 over V1. So V2 is 3.5 liters multiplied by T1, which was 298 K, and divided by 3.75 liters equals. The liters will be canceling. Okay, so bring my calculator back here. 3.5 times 298 equals, divide by 3.75, and I'm getting 278.1333. What am I good for? I'm good for 2 sig figs here. So 278.1 Kelvin is approximately equal to, at 2 sig figs, 280 Kelvin. All right. So, number 4, a container is filled with gas to a pressure of 40 atmospheres, so that's a P. It even tells me it's a P. Standard temperature is 273 Kelvin. What will the pressure be if the container is heated to 45 degrees Celsius? That's a temperature. So adding 273 gives me 318 K, if I did that right in my head. So pressures and temperatures. P1, T1, that's T2. We're looking for P2. The relationship is P1 over T1 equals P2 over T2. Multiply both sides by T2. And I'm going to get that canceling, and P2 equals P1 T2 over T1. So I have 40.0 atmospheres multiplied by 318 Kelvin and divide by 273 Kelvin. Kelvins are going to cancel, equals. So 40.0 times 318 equals, divide by 273, 46.59 atmospheres. So let's look at sig figs. When I add the 45 and the 273, I get 318. That's 3 sig figs. That's 3. Okay, that was 3. I can go to 3. So approximately 46.6 ATM. Okay. Now, one last one for this page. We have 17.5 liters, which is a volume of helium at STP, temperature and pressure. Those all go together. It's heated to 300 Kelvin, T2, and 2 atmospheres, P2. We want to know the new volume. This is the first one we're looking at here of the combined gas law. P1 V1 over T1 equals P2 V2 over T2. Now to get P2, to get V2, that's going to equal P1 V1 T2 divided by T1 P2 equals. A lot of numbers running around here. Standard pressure is 1.00 atmospheres. It's 17.5 liters. T2 is 300 Kelvin. Down here, T1, okay, is standard temperature, 273 Kelvin. And P2 was 2.00 atmospheres. Atmospheres cancels, Kelvin cancels, equals clear. So what I'm going to have is 1.00 times 17.5 times 300 equals, divide that by 273 equals, and divide that by 2.00 equals 9.615. So I'm limited to 3 sig figs here, so I'm going to call that 9.6. And the next number is a 1, but since there's a 5, I'm going to round up and call that 9.62. And the unit is going to be liters. All right, there we go. That's the practice problems on page 4, and in our next video we'll look at the practice problems on page 5. Thanks for tuning in. This is Morgan signing off.